Hello everybody, hope you guys are doing well. So, continuing on our journey, today we would be learning about. Um, so we would continue our DSA journey, and we'll try to complete as many topics as we can, and then we will go on from there. Okay, so uh, let's go. So have you so this is basically I'm going to refer the book, that is Byte by Byte, and we'll see the coding rounds there. So the preface is, so have you ever felt crushing disappointment on being in coding interview and realizing that we have no idea how to find a cycle in the graph, or maybe we have found ourselves second guessing whether to use less than or greater in binary search. So we are not alone. The sheer volume of coding problems is available online can be overwhelming, making it difficult for us to understand on what to focus on and how to tackle complex subjects. The barrier is faced by both novices and seasoned engineers entering coding interview patterns. We are going to see how to master coding interviews, and we'll bring curated collections of essential problems, and then we will see. So prerequisites basically be familiar with at least one language. While familiarity is basically understand the syntax, structures, OOP, basic OOP. Know what simple data structures like arrays and lists. Be familiar with algebra, including algorithms, logarithms, and exponents. By understanding the basis of recursion, how to use, understand how big O notation works. So basically, first is the the way we are going to uh, classify everything is, so first is we are going to study about two pointers. So this is how the book is. So you have two pointers. Okay, so then you have hashing. So then inside hashing you have how to use it in linked list. Then you have binary search, one big thing. Then you have sliding window, then prefix sums. So this is basically tree, I guess. Then further, uh, so we can combine these two, and then something called as heaps. So we'll see, and then we have in heaps basically we have trees. You have the trees. You have different, right, and then okay. So before heaps, you have something called as stack. Then we will see how slow and so in linked list we have slow and fast pointers again. Now, okay. So basically coding, and so now this is how the introduction, right? Now the tech industry's external need has led to, basically these are all topics, right? So we'll see one by one. The tech industries, initially major tech companies like Microsoft led on brain teasers to evaluate candidates' problem solving skills. However, these puzzles were short and assessing a candidate's true competency, experience, and programming skills. So recognizes the industry's move towards coding interviews. During a coding interview, we presented various programming challenges designed to test the knowledge of data structures and algorithms, as well as our ability to write clean, efficient code. So interviewers are not looking for correct solution; they are interested in understanding how would we approach them. So it's important to avoid bugs. Do not stress on minor mistakes. The fixing and debugging is nothing easily. Sure debugging skills and attention to detail. Now, types of coding assignments come in various formats. So, how the different types of formats that we have. First is an online assessment. So you have an uh, you have something. Oh, you have an online assessment. Then you have telephonic. So basically this is telephonic screening. And online assessment, basically it will be timed. This is a time test remote to evaluate your skills and various coding challenges. Now it can have MCQs or it can have some coding problems. Now phone is basically a brief initial assessment, basically 30 to 60 minutes. The inter may evaluate our understanding of the. This is basically towards, it's like a verbal thing, company role. Uh, Now how fit, basically are you a fit to the team? And then technical questions, or it can also contain coding challenges. So then is the one more type is basically take home, right? So this is, you take a home solution. I guess this is not timed. You have to complete it. We can complete it in our own time and space. These assignments usually require coding style, and so this is, we can complete on our uh, own specific way. Last is basically on site, right? So this is like where they give you a technical and sometimes behavioral interviews at company's location or virtually. The coding interview person is basically whiteboard, or we will have an editor. For example, they are looking for how we are. Basically, it's about solving problem, right? Effective communication. Basically, at each step, providing why we did that. Then efficient code again. Did you want something? Optimization is something when you have coded and then you can adaptability and flexibility. Basically, feedback, considering alternative solutions, testing and debugging, productivity test. Now, the negatives are weak fundamentals, poor understanding of basic data structures, algorithms, and programming fundamentals, lack of clarity, thought process, overconfidence, arrogance, or overconfidence can be off. Rigidity, being flexible, or suppose the at some time they point, they may give some hints, right? So then ignoring constraints again, failing to make sure the thoroughness, can edge cases, poor time management, spending too much time on one aspect of the problem. How to approach a problem in an interview? So first is basically, this is a framework, right? Problem clarify. First is basically you clarify what the problem is about. Second step is you write and design an algorithm that will, like, so coding is never the second thing. You design the algorithm. The next step is basically complexity analysis, right? So basically, we'll see. Then comes coding. So after we have done all this, then is when we take a pen and paper and try to code. Like then we have the actual code. So this is all done rough, right? So it's like, this is a rough work. Then again, once you have code, always we have to check for complexity, right? Whether it's time bound. And then is our testing, where we give various different inputs, and then we, so, so there will be some test cases provided to us, right? So we will check whether we are going to reach the test case or not. So basically, in the first step is basically restate or paraphrase it in our own words to understand what the problem. This is basically understanding what is asked. Then is we use to design. So basically, Always start with the brute force method. Never optimize anything. Then a simple solution is better than no solution. More optimal can be built from brute, your brute force. Naive come solution. It's straightforward, describing verbally. Then is uh, so then you do complexity analysis. So that comes now. Then we write code. Then we restate whether we are able to pass that. So it will have some constraints as well, right? So are we able to satisfy those constraints? Then last is basically make sure we are passing these inputs, test cases. Now effective communication. Communication is a very crucial important point in the roles. So basically we need to ask, right? If it's an online assessment, you cannot ask, but then if there is someone in front of you, then we can. Now discuss. So ensure the interviewer is following along. This is crucial but allows us to clarify any confusing they may, and then we can discuss alternative solutions. So for example, if we are stuck somewhere, then we can ask for hint, or we can share our thought process. For example, dead end, right? Thinking time. Sometimes authors will use to think about a problem in a period of silence. Let the interviewer know about it, that we are thinking about it and we are not lost. The 2 pointers. So as the name implies, okay, so we are directly starting with 2 pointers. Or, or so basically, so first data structure that we need to know is basically a array. Basically linear data structure. Now every data structure has some properties, right? Uh, the time to go through all the elements is O of n, where n is basically size of the array. Okay. To remove an element, that is basically in one step, by just going to the index and then removing the element present there. Similarly, adding an element is also O of 1. That will be again going to the index, right? Now, in some languages, arrays are treated as objects, while in some it is still as primitives. Okay. Um, so if it's a now this is basically we are considering about one dimension, right? Basically, this is one dimension. So this is now another feature is in some languages arrays are negative indexed as well. Not in all, but in some. So for example, in most languages arrays are going to be zero indexed, or we will be considering this is zero and this is going up to last. So total number of elements here, when we count from 0, it's becoming n plus 1. If we if you only count from 1 till n, then the elements size will become n. Uh, so negative indexing is reverse indexing, right? So from it starts from years, and so negative index is opposite. Again, not applicable in all languages, only in some languages. Okay, this is fair enough knowledge of about arrays. Uh, okay, not two pointers as a name as it. So first is basically let's see what is this. Uh, mm, First algorithm that we are going to see. So the first we are going to see is two pointer. By algorithm means this is basically what we say set of steps. Now what does it do? As the name implies, a two pointer refers to an algorithm that utilizes two pointers. But what's a two pointer? It's a variable that represents an index or position with a data structure like an array or linked list. Many algorithms just use so in traditional arrays, what is going to happen is, so for example, this is an array, right? So this is one. Say this is up to 9. So in traditional sense, we are going to have one pointer and we are going to increment this pointer so that it keeps on going, right? Now, introducing a second pointer opens a new world of possibilities. Most importantly, we can make, okay, so in what's this? So this is like um we have to pass through all, right? Now what if we add another pointer? Same array. What we do is, so we have two things. We have one pointing to this element and we have another pointing to this. So we have pointer 1 and we have pointer 2. So using this, what we can do is, first thing is we can compare both. That we can compare pointer 1 versus pointer 2. Introducing a second pointer opens a new. Most importantly, we can now make comparisons with pointers at two different positions. You can compare the elements, for example, and make certain decisions. Uh, we can basically compare both. For example, uh, we need to find the greatest element, right? Um, like we can compare any element. So, for example, we can compare this with this. So comparisons can be made. Okay. Now, in many cases, comparisons are made using. So, what if I wanted to compare the same thing? Like, what's the advantage of doing this? So, in one pass, we'll only be able to reach over here, right? We won't need another loop to reach over here. So, basically, comparison will take uh, two times the effort, right? So, the complexity will be off, and we are kind of making comparison in linear search by adding another pointer. Often this approach wherein denotes the length of the structure. If the closed segment below, if I uh, okay, after for example, if I'm using only one pointer. So for example, if I have a single pointer, the single pointer approach will be the single pointer comparison approach. It's going to be uh, for I in some value. Now this is, and then in some this I. Then here is where I'm going to compare a of I and wait. This is basically the compare thing, right? Okay. Often this approach does not take advantage of predictable dynamics that might exist in data. As an example, when we move a pointer in a sorted array, we can predict whether the value being moved is greater. Okay, so this is general approach, right? What would be in single pointer? If if you would have two pointer, right? So we will directly just run a loop, and if we reach that specific index, right? So this is index. So we'll declare two things here: one pointer one and pointer two. Say pointer one is 0 and this is 1, right? So we will keep on going till my pointer 2 reaches a certain index, and then here we can compare, or pointer 2 and pointer 1. So both. So the whole point is using one index you can only one elements, right? So why not uh, have another thing? So this is where we can do our comparison between elements. This is comparing element. The next thing that we have is basically sorted array. For example, if this is 1, so for example, if this is a sorted array, right? Now we all know if it's sorted array means it could be either ascending or descending, right? So value is going, if it's from smaller to greater, values will be increasing, right? And if you have made the other way down, from greater to smaller, then values will decrease. So this is like greater to smaller. So then, but if, so suppose if you want to find the greatest element, right? So we can say, so suppose if we can make use of two things and say, if my pointer one value is say less than pointer two, and this is a sorted array, right? So my, now in between these two, my bigger element is what is pointer two, right? But my array is still there, right? So I need to repeat this until I do this thing until I and keep on incrementing them. So increase to the end and keep on checking at every stage. Basically, what I'm trying to say is, if my if suppose if technically what I'm trying to say is, suppose if number of I is 2, right? Then it is for sure, since it is increasing array, right? I plus 1 will be greater than 2, right? You can make this assumption, right? Because it's monotonic. No, not monotonic, because it's increasing. It's an increasing thing. Now, as not increasing, it is sorted in an increasing order. As you can see, data structure is predictable dynamics. Let us move pointers to a logical way. Now, two pointer strategies. Uh, okay. Now, so now let's see. Now we already know. So there are certain strategies as well. So we already know that we are going to travel the loop only once. Like a comparison will happen only once traversal of array. Now inward traversal in this approach as pointers starting at an opposite ends of the data structure and moving. Okay, so first is there is something called as inward traversal. So basically this is an array, and then so one pointer is going to be at the, so this is, if this is one, okay, so this is out, this is pointer say, and this is pointer one, close. Yeah, so this is pointer one and pointer two, right? So inward is going towards the center. This is the center line until we cross, this crosses the center and comes on the other side. This is crossing center and coming on the other side, and this is crossing and going. So until there is a cross, the unidirectional traversal. In this approach, both the pointers start at the same end of the data structure, usually the beginning, and move in the same direction. These two pointers generally serve different but supplementary purposes. A common application is you want to find information, another to keep track of information. Okay, so for to invert traversal, so the condition will be crossing or some condition. Okay, fair enough. Then we have something called as unidirectional traversal. Unidirectional name suggests one direction traversal. In this approach, both pointers start at the same end of the structure. So, for example, one, two. So this is pointer one, and this is also pointer two. Now, what we are going to do is when we want one pointer to find information, usually the right pointer, and the other to keep a track of the information. Mm. What should be the keeping a track? We need to keep a track of information. What information are we tracking? So this is something like if you want to track something, store or track. This is basically crossing, right? Whenever you want to cross or some condition is met. Then we have the last one is stage travel. In this approach, we traverse with one pointer. When it lands on an element, that means a certain condition will traverse with the second pointer. This is staged. Okay, so this is What is staged? What is staged traversal? Staged meaning. Staged means in a step. Similar to unidirectional, both pointers serve different purposes. The first pointer is used to search for something, and once found, the second pointer finds additional information concerning. Okay, so basically, it's a two-step process, like two stage or step. We'll see like how to s- understand more. Now, when to use two pointers? Two pointer is basically when we require a linear search, right? Whenever we are requiring a linear search in a data such as an array or a linked list. Otherwise, an indication that a problem can be solved using two pointers is when the input follows a predictable dynamics, the sorted array. Okay, so now when to use? First, first is like directly array search, right? If it's any something that is going to involve two searches. No, no. This requires a first is the first condition is it has to be a linear data structure, such as an array or a linked list. Otherwise, an indication that a problem can be solved using two pointers algorithm is when the input follows a predictable dynamic. Or intuition is when we have when input has something a predictable like as a predictable or when it specifically mentions that arrays are increasing. Now whatever is there is always going to increase or it is going to decrease, or you can club them and say this is going to be sorted, right? Now sorting can be done in two ways, either in increasing or in decreasing manner. So basically, so sorting again increasing manner, or you have decreasing, but say similar things. The real one example, garbage collection algorithm in memory compactions. Okay. So basically now our goal is to understand where all okay. And one more thing that we want to see is linear data structure. I mean, when can we say it as a linear? So when we mean to say a linear data structure, elements are arranged one after the other. There is no hierarchy. There is no hierarchy. Each element has a logical successor or a predecessor. Single level organization traversal, one element at a time. So traversed linearly, like one element. So for example, arrays could be thing. Now stacks and queues are basically uh, a way in which you are implemented using arrays, right? These are also coming here. Second is even a linked list, right? Linked list also has a predecessor and a successor, all elements. So even if you consider these things, even if you consider these elements, right? Have a predecessor and successor. So this is the thing that we need to keep in mind when we are uh, dealing with a two pointer approach, right? So basically, I got a now. So basically, how we can classify two pointers? So even in two pointers, depending upon how we traverse it, there are three ways, right? First is uh, first is when both the pointers start at the same and go to the end, right? So that is one directional transaction, one directional tran- tra- traversal. So that is unidirectional. This is useful when we want to uh, save something, probably. Okay. Next thing that we have is it's inward. So inward traversal is start at one end and go inwards until there is a cross or a condition being met. Okay. Unidirectional is one directional going. Basically, here is when we need to come um like next has to be compared with previous. I guess that is unique. And the third is staged or in step. That means um you have different uh, st- steps. Like now both pointer one and pointer two do not move simultaneously. Pointer. So for example, if I am saying pointer two moves only after pointer one reaches a condition. So basically, this is in step, right? You're not moving them in one go. You're moving them in different steps. Okay. Yeah, so I guess that is all for this session. I hope you guys liked it. I'll see you guys in another one. Till that time, take care. Bye bye.